In this video, I'm going to go over AP Precalculus to Unit 3, Part 3. We're going to review the three sections on polar coordinates. So this is 313, 314, and 315. So in polar, our grid looks a whole lot different than the regular rectangular / Cartesian plane. Rather than measuring things horizontally and vertically, we're measuring it at different angles and different distances away from the pole. The coordinates in polar are always an r followed by a theta instead of an x and a y. So when we plot points in polar, we're looking for the angle and then how far out we are. So 5 pi over 6 is going to be here, and we're going out 1, 2, 3, 4 units. Okay. Next one, we're going to find 4 pi over 3, which is down here, and we're going to go out 5 units. When we have a negative angle, like in these two, our angle is going to be measured going clockwise rather than counterclockwise. So a negative 7 pi over 4 is going to go this direction 7 pi over 4. Positive 7 pi over 4 goes this dimension. This is negative 7 pi over 4. Okay, and then negative pi would be here, which is the same as pi, because pi goes this direction, negative pi. But we're going to go 2 units out there. When we have a negative r value, we're going to find our angle, so in this case pi over 4, but rather than going for this direction, we're going to go through the pole to the opposite side and go for that direction. So here we're going to find 2 pi over 3, which is up here, and go through the pole to the other side. When it's a negative negative, it's going to be a clockwise angle and then through the pole. So negative 7 pi over 6 is going to be right here, and we're going to go through to negative 5. And then here, negative pi over 2 is here, and we'll go through to the other side, 3 units. So unlike the rectangular or Cartesian plane, there's an infinite number of ways we can label a single point. So like this could be for 2 pi over 3, or it can go clockwise to that same idea. So what we're going to do is come up with 3 other coordinates between negative 2 pi and 2 pi, because we could just keep adding 2 pi. So for this one, I'm going to come up with an equivalent one with a positive r, negative theta, a negative r, and a positive theta, and then a negative, negative. I find it helpful to graph. If you don't have a graph, just make yourself a little circle to help you out. But 2 pi over 3 is here, so here is 4. Okay. So we're going to come up with the equivalent points going these other directions. So first, a positive, negative. We want to go to that same point, but we're going to go this direction. So that's going to be 4 pi over 3. With a negative r, positive theta, a couple different ways to think about it. You can go 1, 2, 3, 4 here and see what counterclockwise angle you'd have to get to. Or we can go through the pole, find that angle, which is going to be a 5 pi over 3, and then it goes through to the other side. So we have a negative 4, positive 5 pi over 3, and you can always check. If I go to 5 pi over 3, we're here, through the pole gets me to where I want. Negative, negative, again we can go here and go clockwise to that angle, or we can go to our opposite side and figure out what angle that would be as a negative, which both cases gives me a negative pi over 4, or pi over, negative pi over 3. Okay, next one, negative 3, 7 pi over 6. So here we're going to find the equivalent positive, 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 negative, and negative, negative. Okay, and again, I will go ahead and graph that. So 7 pi over 6 is here, but we're doing a negative r value. Okay, so a positive positive is going to be a positive 3 positive pi over 6. A positive negative means we're going all the way around here, which is going to be 11 pi over 6. And finally, negative negative is going to be a negative 3. So we're getting to this point. So if I go through, there's negative 3. This angle as a negative is negative 5 pi over 6. My last one for negative 3 pi over 4. So I'm looking for the positive positive, the negative positive, and again the negative negative. So start by graphing. Okay, so negative 3 pi over 4 is here. So my positive positive will be a positive 4. Positive 5 pi over 4. The negative positive would be this angle here, which is 3 pi over 4. Sorry, negative positive. So negative r positive theta. So positive theta, apologies, is going to be pi over 4, negative 4. Okay, and then the last one is going to be the same angle that we did here, but going clockwise. So a negative 4, negative 7 pi over 4. Next, we're going to convert to our regular rectangular coordinate system. So given an r and a theta, to get x and y, x is going to be r cosine theta, y is equal to r sine theta. Cosine always goes with x, just like on the unit circle. Sine always goes with y, just like on our unit circle. So I have 4 problems here that I'm going to work through, but it's always just r cosine theta, r sine theta. So for this one, x is going to equal to cosine pi over 3, and I'm writing this separate, but you could certainly just write this in a coordinate and work it out that way. So r sine theta for y. Then we'll evaluate using our knowledge of the unit circle. My x value at pi over 3 is 1/2. So this gives me a 1. My y value at pi over 3, it's my long y value there, so root 3 over 2. So my coordinates here are 1, root 3. Same deal. Okay, so we're still just going to go to 5 pi over 6 and evaluate that, which gets us negative root 3 over 2 and positive 1/2. So my result is a 5 root 3 and a negative 5/2. It should match quadrants, so this would end up being in the 4th quadrant. And here, if I were to graph, 5 pi over 6 is here, but if I go through the pole, we end up at that same spot. Next, we'll do 3 and negative 3 pi over 4. Okay, so again, our cosine theta, our sine theta. Here, we're getting the sine and cosine values from negative 3 pi over 4. So rather than going here to 3 pi over 4, we're going here to negative 3 pi over 4. So it's the equivalent coordinates as 5 pi over 4. So both of those, x and y, is negative root 2 over 2. So my final coordinate will multiply to get negative 3 root 2 over 2 and negative 3 root 2 over 2. The final coordinate I'm going to work with is 1 and pi over 2. So we have 1 times cosine pi over 2, 1 times sine pi over 2. At pi over 2, my cosine value is 0, my sine value is 1. So this is the coordinate 0, 1. And again, think about this graphically. Here would go straight up to pi over 2, out 1 unit. Here would go up 1 in the y-axis. Next, we're going to go the other direction. So the formula is if we know x and y and are trying to get r and theta, my r is the square root of x squared plus y squared. Now it certainly can be negative, but we're going to try to make our lives easy with the positive one. Theta is going to be the tangent inverse of y over the x in the correct quadrant. We're doing this all without a calculator, which means we just have to use our knowledge of the unit circle to find the tangent values and the corresponding angle in the correct quadrant. Okay. So first one, r is going to be the square root of 1/2 squared plus, I'm squaring this, so I'm going to be a little bit lazy and ignore the negative, because if I turn around and square it, it's going to go away anyway. So save that precious ink. So when we square this, I get 1/4 plus 3/4. Add those together is going to be 1. Square root of 1 is 1. My theta is going to be the tangent inverse. The negative matters here, so we'll include that. So when I simplify, the 2's cancel, so we just end up with root 3 over 1, which is root 3. Negative root 3. So first off, tangent is negative in both the second quadrant and fourth quadrant. This one is in the fourth quadrant. The root 3's are down towards the bottom of the circle at the pi over 3's. So this is going to be 5 pi over 3. Okay, next. So working through this one, 4 squared is 16, root 3 squared is 3. This is going to give me 48. When I add that to 16, I get the square root of 64, which gives me an r value of 8. Okay, so then we do tangent inverse of the y over the x. This is going to simplify down to just a positive 1 over root 3. Tangent is positive in the first and third quadrants. We are looking for the third quadrant angle with this value. That's going to be 7 pi over 6. So the root 3's are down at the bottom. These ones are close to the x-axis that are pi over 6's. Next is going to be 3. Okay. R for this one, 3 squared plus 3 squared is 18. Which is 9 times 2. So since 9 is a perfect square, we can simplify that to 3 root 2. To get our theta, it's going to be the tangent inverse of 3 over 3. 3 over 3 equals 1. Tangent is 1 in both the first and third, but we're looking for first at pi over 4. So this rectangular coordinate is 3 root 2, not 3, pi over 4. This last one here, I'm going to actually just do by graphing. If I were to graph the point -5, 0, okay, that's going to be here. Thinking about this as a polar plane, it's going to be 5 units out. The theta is going to be pi. So we can just use the graph and get those values. Okay, we can do a similar thing to what we just did. With complex numbers. This is going to behave like the coordinate 3, which we actually just found its r and theta values. It's just the structure for the polar number is a little bit different. So the polar number in complex is going to be r cosine theta plus I r sine theta. So we still need to find the r value and the theta value. It's just the structure is not a coordinate anymore, it's a polar point. So this first one, like we said, we've done the math on this one already. Okay, so we still calculate r and theta the same way. So 3 squared plus 3 squared is 18, which simplifies to 3 root 2. Tangent inverse of 3 over 3 is still tangent inverse of 1, is still pi over 3 in the first quadrant. But when we put all this together, it's not a coordinate. It's a 3 root 2 cosine pi over 4 plus I 3 root 2 sine pi over 4. Now I've seen polar numbers in different formats. I've seen it with the r's factored out, so that would be 3 root 2, and then in parentheses cosine pi plus I, or pi over 4, plus I sine pi over 4. A shortcut is just to do 3 root 2 cis pi over 4. It's kind of a shortcut for the cosine and the I and the sine. But this is the structure that AP has presented. This next one, if I were to graph -1, okay, we're over here again. So my r is going to be 1. My theta is going to be pi. So this is going to be 1 times the cosine of pi plus I, 1 times the sine of pi. And then we'll do one more here. R is going to be the square root. Again, I don't care about the negatives in this part of the calculation. So we're going to have 1 plus 3, which is 4. Square root of 4 is 2. Theta is going to be a negative root 3 over -1. So we're looking for tangent inverse of positive root 3 in the third quadrant, which will be down at 4 pi over 3. So put it in our structure, 2 cosine 4 pi over 3 plus I, 2 sine 4 pi over 3. Going the other direction is very simple. We just simplify this. So I'm just going to evaluate here what the cosine of 11 pi over 6 is, which is going to be a positive root 3 over 2. Sine at that same value is a negative 1/2. So we're going to end up with 4 root 3 minus 4i. Do the same thing here. It's just our angles are going to be negative. So negative 3 pi over 4 is down here, same as 5 pi over 4. So this will be 6 times negative root 2 over 2 plus I, 6 times negative root 2 over 2 again. So this will be a negative 3 root 2 plus 3 root 2 I minus. Those were all from our first section, 313. 314, we started getting into graphs. The graphs of polar equations can look really cool. Lots of things we can do there. Here we're going to be doing some matching. So there's some shortcuts that I'm going to show you, but there's also some good tried and true methods that are going to work also. Tried and true would be to graph each of these rectangularly and then match that information with here. You're looking for, one's going to have a value at pi over 2, 5. One's going to have a value at pi over 2, pi, and so on. So that's sort of a longer method, but absolutely will work. Some shortcuts, when we have just a normal kind of classical polar curve, if our graph is a sine, it's going to be symmetric to the y-axis. If it's a cosine, it's going to be symmetric to the x-axis. Okay, so kind of a shortcut there. That means these two are my sines, these two are my cosines. So let's look at these two. I'm going to go ahead and plug in pi over 2 to see which one I get 5, and one of them I'm going to get a 0. Okay, well, sine of pi over 2 is 1. So in this one, I'm going to get a 5. In this one, I'm going to get a -1. Okay, so at pi here, we're at a positive 1 and a 5, so this is going to be A. Here at pi over 2, we're at negative 1, which is going to give me this graph being B. Okay, same thing with the cosines. In this one, I'm going to plug in 0 to see what happens. Okay, so cosine of 0 is 1, so this one gives me an R value of 5. Cosine of 0 is still 1, so this would be 2 minus 3, which is negative 1. So we get those same two values, it's just now going to be on the x-axis. So this one at 0 went to negative 1, this one at 0 went to 5. So this one is my D, this one is my C. But again, if that's uncomfortable, you can plug in more values or graph the rectangular equivalents of these and see which one matches the coordinates that we're looking for. Okay, next, similar idea. We have four equations, four graphs. These are all roses. So one shortcut is knowing what the theta, what the coefficient of the theta gives you in polar, specifically for roses. These two are going to have 3 petals because when that number is odd, between 0 and 2 pi, you're going to see 3 petals. Now, technically, it's going to be 6, but they graph on top of each other. If it's even, you end up doubling it, so these two have 4 petals. Okay, so these two go to these ones, these two go to these ones. Using symmetry, if I have a sine, it's going to be symmetric to the y-axis. If it's a cosine, it's going to be symmetric to the x-axis. Or you can plug in 0. If I plug in 0 here, sine of 0 is 0. So we'd get 0. Here, if I plug in 4, we get a 4, which is why here there's nothing at 4. Here there is at 4. Or go back and graph the rectangular graph. We're going to be doing that for a later example, but you could graph all 4 of these and then see where the petals ended up, and that's tried and true way to figure this out. This one, again, at 0, this one's at 4, this one's not at 4. Here, if I plug in 0, sine of 0 is 0, so I get 0. Cosine of 0 is 1, so I do get a 4. So this one is my cosine one, this one is my sine one. Or graph it rectangularly and you will get those petals very easily that way. Okay, so here I have 4 sine 2 theta, and we just have portions of that graph. And we're going to figure out which of these gives me these intervals, another matching problem here. So I'm going to graph the corresponding rectangular graph, which is going to be y equals 4 sine 2x. And you'll see how we could have applied this to that last problem very easily. So the amplitude on this is 4. The period is 2 pi divided by 2, which is pi. I'm going to graph 2 cycles of this, so in pi and then out to 2 pi. So I'm going to cut this up into 4 pieces, so cut that in half to get pi over 2, cut that in half to get pi over 4, 3 pi over 4, and then we'll do the same thing here. This will be 3 pi over 2, 5 pi over 4, and 7 pi over 4. Okay, so I'm graphing a sine curve, which starts at the midline and goes up. Kind of missed that one. It's okay. All right, so like I said, we could have done this on the last problem because this one here is going to have 4 petals between 0 and 2 pi, 1 at pi over 4, 1 at 3 pi over 4, but negative 4, 5 pi over 4 at 3, and then 7 pi over 4 at -4. So that would match to the graph that had 4 petals at all of the 45s, or all the pi over 4s. Here we have that same thing, but just portions of it. So I'm going to match this to this, and we'll talk about how this translates to a full petal versus half a petal. For a full petal, we're looking at starting at 0, going out to 4 in this case, and then back to 0. If we're just going from 0 to some number, that's going to be just a half of a petal, which would be from like a maximum to here or a 0 to here, depending on which side. And then this one would be 2 half petals, just not the same petal. So looking at our values between pi over 4 and 3 pi over 4. So pi over 4 to 3 pi over 4 has a the part of the second half of the first petal and the first half of the second petal when graphing. So if I were to do this, we'd start at 0 and then go out to this point, which would be 4 pi over 4. And then it would loop around to here, which is going to be this one, which is at 4 negative 3 pi over 4. So this one is our A. Pi over 2 to pi is a full petal. We're looking for 3 pi over 4, but negative 3. So 3 pi over 4, but negative 3 is going to be this one. And it's a full loop because it starts at 0, goes to 4, back to 0. So this one is B. Okay, 5 pi over 4 to 3 pi over 2 is just half of a petal. The only one that has that is this one, but just to show you, we're starting at pi over 4, and then it travels back to 0. So this one is C. And then from pi to 3 pi over 2, again, is another full petal. Process of elimination, it's this one, but what we're looking for is at 5 pi over 3 to be out at 4. So that's that coordinate there. So that's my last one. The last section, 315, we talked about increasing and decreasing. So specifically, the distance of a point increasing from the origin or decreasing from the origin is that distance. So what we're going to look for is the polar curve, or the rectangular curve. So I'm going to look at y equals 2 plus 4 cosine x, because I'm going to be able to see where it's moving towards and where it's moving away, and then we're going to justify our answer. This has an amplitude of 4, a period of 2 pi, and a vertical shift of 2, which means my midline's at 2, and we're going 4 above that and 4 below that. So my maximum is going to be 6, my minimum is going to be at negative 2. Okay, we are graphing a positive cosine, so that's going to start at the maximum, to that middle at 2, minimum at negative 2, and back up. So just in general, if our graph is positive and decreasing, our points are moving towards the origin. If it is negative and decreasing, it moves away from the origin, which means our distance is increasing, but then it starts moving back towards the origin, which means my distance is decreasing. Then in this last section, it is positive and increasing, so those y values are pulling away from our origin, which means our graph the distance is increasing. Okay, so I walked through all that. Let's label all these. First, I need to find this location and this location. So what I want to do is set this equal to 0 and solve to figure out where it's crossing the x-axis. So we're looking for where cosine theta is equal to a negative 1/2. That's going to occur at 2 pi over 3 and 4 pi over 3. Okay, so this is 2 pi over 3. This is 4 pi over 3. So my first, I'm going to look at increasing. I said, I'll just go step by step. So starting at 0, going to 2 pi over 3 is decreasing. My reason is because the graph is positive and decreasing. Okay, so it's above the x-axis, but my values are getting closer to the x-axis, which on the polar plane means my graph is getting closer to the origin. From here to here, we're negative, but getting more negative. So we're pulling away from the x-axis, which means when I graph this, we're going farther from the origin. So that is going to be increasing. Until pi, because our graph is negative and decreasing. Okay, then starting at pi, it's still negative, but now it's increasing, which means it's moving away. And that second point was 4 pi over 3. Our justification is because it's negative and increasing. Then the last section is positive and increasing from 4 pi over 3 to 2 pi. This one is because it is positive and increasing. Okay, so the values are getting farther away from the x-axis and farther away from the pole. Okay, we're going to do the same thing here. I'm going to start by graphing the rectangular graph. So this one has an amplitude of 4 and a period of 4 pi. No vertical shift. And it's just a sine curve. So sine starts in the middle, goes up. All this prior knowledge is coming in handy. Okay, so this one, I'm going to write all this out, but my graph is increasing and positive, so my distance is increasing here. My graph is positive and decreasing here, so our values are decreasing. Here we're negative and decreasing, which means my distance is increasing, and then we'll start going back, so my distance is decreasing. Okay, putting all that together, like I said, 0 to 2 pi, so we're increasing, decreasing, increasing, decreasing, because when they're matching, positive and increasing or negative and decreasing, we're going away from the pole. When they're opposites, positive decreasing, negative increasing, they're moving towards our pole. The last topic I'm going to go over is how average rate of change looks like on the polar plane. Good news is, same calculation. The average rate of change is always f of b minus f of a over b minus a. It's a little bit flipped though because it's not y over x, it's going to be our R values over the theta values. Our inputs are the thetas, our outputs are the r's. This will not correspond to the slope on the polar plane. It does on the Cartesian regular plane, but here it's just going to show what the change in the average change in the r values. So for this one, we're going to have f of pi minus f of pi over 2 over pi minus pi over 2. I'm going to do these calculations separately. Okay, so cosine of pi is -1, so we're going to get a 2 out of that. Cosine of pi over 2 is 0, so we're going to get 5. So this is now 5, or 2 minus 5. over pi over 2. So we get 3 over pi over 2. Sorry, thinking ahead. Which is going to give me 6 over pi. So we've got one more to do. Same process though. This will be f of 7 pi over 6 minus f of pi over 2 over 7 pi over 6 minus pi over 2. So f of 7 pi over 6, we've got 4 plus 4 sine 7 pi over 6. My y value at 7 pi over 6 is a negative 1/2. So I get 4 minus 2, which is 2. Pi over 2 up at the top of our circle is 1, so we get 4 plus 4, which gives me 8. So I get 2 minus 8 over, I'm going to get a common denominator here, so that's going to be 7 pi over 6 minus 3 pi over 6. So that's a negative 6 over 4 pi over 6. Which is going to be a negative 6 times the reciprocal of this reduced is 3 over 2 pi. So that's going to be a 3 times 3, so I get a negative 9 over pi. Okay. So that was topics 313, 314, and 315. Thank you for watching.